Alrighty, howdy folks. So today, let's look at, let's look at section 11.8. It is about power series. And as any mathematician would, let me start with the definition. What's a power series? The definition is something like a power series centered about A is of the form sigma c sub n x minus a to the n equals 0 to infinity, sigma n equals 0 to infinity c sub n times x minus a to the n. So this is the nice sigma notation version of that power series, right? So let's ask ourselves, could we just expand this out and write term by term, something plus something, so on? For that, we need to start by plugging in n equal to 0 in order to get the first term, right? So let's do that. If you plug in n equals 0, what do we get? This becomes c sub 0. Just leave it alone, call it c sub 0, times x minus a, the quantity raised to 0. Well, x minus a, any number raised to power of 0 is 1, provided that number is not equal to, the base is not equal to 0. 0 to the 0 is not equal to 1, okay? 0 to the 0 is undefined. Let's not mince words there. So x minus a to the 0 is 1, and we have c sub 0 times 1, which is just c sub 0. So the first term is c sub 0. As simple as that. A second term, let's plug n equals 1, increment n, by 1, and so we get n equals 1. So c sub 1 times x minus a plus c sub 2 x minus a squared, and so on. So this is how a power series looks like. A whole bunch of questions. What in the world are these c sub 0, c sub 1, c sub 2? They are just constants, some numbers, some constants. As simple as that, right? But what's the difference between this series and the series that we were looking at all these days? The difference is, notice how in this series there is a variable x. Up until now, we had only constants, right? For example, our series looked like 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5, and so on. So it just looked like the terms were all just constants. But now in a power series we have variable x, and boy, very, very powerful stuff. So many things at an advanced level are done using power series. It's a good idea for us to get a good hang of this one. All right. Okay, where c sub 0, c sub 1, they're all constants. All right. Example. What does a power series look like? Let's look at this. Sigma n equals 0 to infinity x to the n over the quantity n plus 1 squared. Is that a power series? Does that look like sigma n equals 0 to infinity c sub n times x minus a to the n? Yeah, it does. But there is no x minus a, man. Yeah, what if my a is 0? How would x minus a look like? It would look like x, right? So x minus a, the quantity raised to n, here is nothing but x minus 0, the quantity raised to n, by which we are saying, hey, in this case, that a, which is what does a represent? It's the power series is centered about a. So this power series is apparently centered about 0. Okay. Now x to the n over, what are c sub 0, c sub 1, c sub 2, or what is c sub n? Whatever x to the n is multiplying. What is x to the n multiplying in this case? 1 over the quantity n plus 1 squared, right? So c sub n is 1 over n plus 1 squared. 1 over the quantity n plus 1 squared. Okay, let's figure out the expanded version of it. And I'm sure you would agree, I plug in n equals 0, we get x to the 0 is 1, 1 over 0 plus 1 square is 1, so 1 plus x over 2 square plus x square over 3 square, and so on. Right? Okay. So, looking at this, can you tell what C sub 0 is? What is C sub 0 in this original power series? It's just the constant in the series. In the expanded version, whatever is the constant is the C sub 0. Here the constant is 1, meaning it's not being multiplied by any terms like an x or x square or anything like that, right? So that's a constant. So C sub 0 is 1. And we already established that a is 0, so C1 times x. So what is C1? The coefficient of x. What is the coefficient of x? In other words, in this case, in our case, what is x being multiplied by? 1 over 2 square. So C sub 1 is 1 over 2 square. By a similar argument, C sub 2 is 1 over 3 square, C sub 3 is 1 over 4 square, and so on. So definitely we do have a power series here, right? That's the idea. Now, maybe I could go ahead and say something here. All right. So here we have a power series centered about 0. And the way it is different is we have, in each term, we have this variable x. But x is a variable, which means is an independent variable especially, which means we can give it whatever value we want, right? Let's say we give a value of 1 to x. In the event x is 1, what does this series become? It just simply becomes 1 plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square, and so on. Or, sigma notation wise, 1 over n plus 1 square, the quantity n plus 1 square. Now you ask the question, does that series converge? Does sigma 1 over n square, we can rewrite this as n equals 1 to infinity 1 over n square, and you get the same series. So does that series converge? Yeah, it's a p series. Sigma 1 over n square is a p series with p equals 2 greater than 1. So the point I'm trying to drive at here is, when we look at a power series, we are interested in whether it converges, and if it does converge, for what values of x does it converge? Right? We'll cover that in detail, but I just wanted to give you a heads up on what we are about to do. So given a power series which has a variable x in it, we are interested in whether the series converges, and if it does, for what values of x does the series converge? Okay. Now notice, for x equal to 1, this series converged because it's a p series. If I just make it into 2, x equals 2, then we have 2 to the n over n plus 1, the quantity square, sigma. That is a divergent series. How do I know that? Apply test for divergence. Limit of 2 to the n over n plus 1 square is infinity, because the top is an exponential function which goes to infinity faster than the bottom does, right? So limit of a sub n is not equal to 0. Therefore, we should conclude the series diverges for x equals 2. So we saw that for x equals 1, the series converged, but for x equals 2, it did not, right? So that's the key here. We need to figure out for what values of x the series converges. That's the idea. Cool. Let me continue. If I wrote like this, notice I'm not using any sigma notation or anything like that. I'm just giving the expanded version, and I'm asking you, is this a power series? In other words, does this look like that C sub n sigma, or maybe I should compare with this one because I didn't give the sigma notation for it. Does the series look like C sub 0 plus C1 times x minus a plus C2? Does it look like that? Yeah, it does. Sorta, right? Wait, what is C sub 0? Meaning, what's the constant? Oh, there is no constant. Oh man, there is no constant here. It's not a power series. No. Don't jump to a conclusion like that. Because that constant C sub 0 could very well be 0. And in fact, it is equal to 0 here. Right? So C sub 0 is 0. Okay. Then we have x minus C sub 1 times x minus a. Oh, what is a? A is clearly 2. What is C sub 1? C sub 1 is the coefficient of x minus a, which means the number, the constant that is multiplying x minus a, or x minus 2 in this case. And that constant is 1 over 1 factorial. So C sub 1 is 1 over 1 factorial. What is C sub 2? C sub 2 is the coefficient of x minus a, the quantity square, or x minus 2, the quantity square in this case. What's the coefficient of x minus 2, the quantity square? Again, there is no x minus 2, the quantity square here, man. Yeah, that means C sub 2 is 0. Okay. However, C sub 3, I'm sure you see that it's 1 over 3 factorial, and so on. Cool. So here C sub 0 is 0, C sub 1 is 1 over 1 factorial, C sub 2 on the other hand is 0, C sub 3 is 1 over 3 factorial, and 4, 6, 8, all the even ones are 0. Now consider the power series, this one, and let me ask you, when x equals a, remember, x is an independent variable. We can make it out to be whatever number we want. So let's say x is equal to a. Then what happens to this series? For that, I want to suggest that you go to the expanded version and not the sigma notation. You gotta feel free to be able to jump from one notation to the other one. Sometimes it's good to see it in the sigma notation, sometimes in the expanded notation. So in this case, I would suggest to answer this question, what happens to this power series when x equals a? Look at this one. C sub 0 plus C1 times a minus a. Oh, that just goes to 0. So the whole thing goes to 0. The second term goes to 0. Third term, hey, that also goes to 0. Fourth, fifth, sixth, nth, every term goes to 0 except C sub 0. So in the event x is equal to a, this whole big infinite series reduces to a single term C sub 0, right? Now, can I ask you about the convergence of this series? Does the series converge for x equal to a? Think about it. The answer is, of course, yes. Because when do we say a series is convergent? When the sum is a finite number. What is the sum of this one term, C sub 0? C sub 0. All the other terms are 0. So when you add up all the other 0 terms plus the C sub 0, you get C sub 0. So the sum of this power series when x equals a is clearly C sub 0, which is a finite number. So we have to say the series does converge for x equal to a. Right? In fact, we can make a generalized statement. A power series always converges for x equals a. Always. A power series, sigma n equals 0 to infinity, c sub n times x minus a to the n, converges for x equals a always. Keep that in mind. All right, another definition. If a power series converges whenever absolute value of x minus a is less than r, then we say that r is the radius of convergence. Let's see what in the world this means. What I'm attempting to do with this number line here is get you to see what it means to say absolute value of x minus a is less than r. What does it mean? Okay, check this out. On a number line, we would have 0 and a is located somewhere. A is just a number, right? Some constant. So let's say a is located here. Hey, how come you put it on the positive side, man? I didn't have to. Maybe I could have put it anywhere on this number line. Okay. Now, if we were to draw a one-dimensional circle with a as center and r as radius. Did I say one-dimensional circle? Isn't that crazy? There is no one-dimensional circle, man. There's only two-dimensional circle. Okay. Can you draw a three-dimensional circle? If I say, yeah, three-dimensional circle is nothing but a sphere. Right? In fact, you can think of it like that. You can think of a sphere as a three-dimensional circle. In the same way, we can talk about a one-dimensional circle. What that simply means is something like this. With A as center, just cut off arcs. Don't draw the full circle that goes all the way around, because this is defined only in one dimension. So that circle, quote unquote circle, cuts this line at this point and at that point. Okay. Now, what we mean by absolute value of x minus a is less than r is this interval. What do I mean by interval? I mean all the set of points from a minus r to a plus r. So basically, that is just an interval, a set of points. Now, an easy one way to refer to that is with absolute value of x minus a being less than r. Where did I get this idea from? Well, for that, go back to your pre-calculus days. We learned that when absolute value of x minus a is less than r better be a positive number. Absolute value of x minus a is less than r automatically means negative r must be less than x minus a less than r. This is the inequality that you would get when you write this. Now, once we have this, notice we can add the same term to every one of the terms, and that does not change the inequality. You agree with that? If we have an inequality like this and we add the same term, same number to every one of these things, then the inequality does not change. So let's add an a. This becomes negative r plus a. Negative r plus a is same as a minus r. And x minus a plus a, negative a plus a add up to 0, you get x, r plus a, or a plus r. So that's what we get. And what does this in turn mean? A minus r less than x. That's a fancy way of saying x lies between a minus r and a plus r. Right? X lies between a minus r and a plus r. Isn't that precisely what we are showing in this on the real number line? X that we pick is going to lie between this a minus r and a plus r, which represents all this set of points in between. Cool? All right. And what we say is, now pay attention. Now let's go to the definition. If a power series converges whenever absolute value of x minus a is less than r, immediately I'll pause there and say, and rethink of this statement this way. If a power series converges whenever x lies between a minus r and a plus r, right? Then that r is what is radius of convergence. Keep that in mind. We will apply it to a whole bunch of cases. Which is this interval. Okay, got it. Ooh. So it is important to remember that when the radius of convergence is r, the power series converges for all values of x that are in the interval a minus r to a plus r, the open interval a minus r to a plus r. What's up with that open interval, man? Open interval is, that means the endpoints are not included. Had the endpoints been included, we would have made this left parenthesis into what? Yep, you guessed it. We would have made it into a square bracket, right? Similarly, the right point is not included. A plus r is not included. And so we do not make it into a square bracket. As simple as that. Okay. Now, let me illustrate this concept with a few problems in exercise 11.8. Find the radius of convergence and something called interval of convergence of the power series. Okay. By the way, interval of convergence is nothing but this a minus r to a plus r. Figure out a minus r to a plus r and you got the interval of convergence. However, there's something else that you need to do. We'll talk about it. All right, find the radius of the power series, this one. Okay, so what am I asking basically in a simple thing? Hey, for what values of x can I plug in so that this series actually converges? Will it converge when x is equal to 1? Will it converge when x is equal to 2? And so on, right? So that's what we're looking at. And the way to handle this is, we will almost always, note this is a power series, blah, blah, a equals, yeah, maybe I should point that out. Note that this is a power series of the form with a equals 0, right? Clearly, x minus a, the quantity to the n, a must be 0. That's why we have x to the n. And c sub n, any ideas what c sub n is? C sub n is negative 1 to the n over cube root of n. However, notice this is starting from n equals 1 to infinity, so n must be an element of the natural number set. What? Okay. Can I ask you what c sub 0 is? Think about it. C sub 0 is actually 0. There is no constant in this. Like when you plug in n equals 1 to get the first term, you already have an x to the 1. So there is no constant at all. So c sub 0 must be 0. Okay. Now, to find the radius of convergence. Now, you better be good with all those 140 problems in order to be able to do this. In just about every case, we'll apply ratio test, maybe at most a root test when the thing demands it. Okay. For the most part, in order to find the radius of convergence, we will apply ratio test, at least as a starting point. Okay. What's ratio test? Oh, that's where we keep that hand. By the way, if you don't remember exactly what the ratio test is, keep that handout ready on test for series and look it up. For ratio test, we need to figure out limit of absolute value of a sub n plus 1 over a sub n. Right? So let's figure that out. Wait a minute. Since I'm taking absolute value, do I need to worry about that negative 1 to the n? I don't, because the moment you take absolute value of negative 1 to the n, it just becomes 1. Meaning regardless of what n is, whether it is 0 or whether it is odd or even, -1 to the n when you take absolute value will always be a positive 1. So we can just pretty much throw that out. Okay. Excuse me. Sorry, needed to get a drink. So -1 to the, let's see, ignoring that -1 to the n, a sub n plus 1 will have a x to the n plus 1, which can be written as x to the n times x, over cube root of the quantity n plus 1 times cube root of n over x to the n. I just multiplied by the reciprocal of a sub n instead of dividing by a sub n. X to the n's cancel, and this reduces to simply, maybe I'll go ahead and show that. Hey, I thought the x was supposed to be inside, man. Well, can I pull the x outside of the limit as absolute value of x? Am I allowed to do that? When can we pull some constant, when can we pull something outside of a limit? When we have a constant multiple, right? So am I claiming that absolute value of x, which is a constant multiple, that I can pull out like that? Well, yes. But I thought you said x is a variable. Yeah, but in this context of taking a limit as n approaches infinity, the variable is n. So you can treat x as a constant. That's why we could yank it outside of the limit. That's the concept. Okay, so we pull this out. Now what in the world is this limit equal to? How about this? In the denominator, let's eliminate plus 1, ignore plus 1 in favor of n, because n is going to infinity. Adding a 1 to it ain't going to make a difference. So just ignore that. So we have cube root of n over cube root of n, which is 1. So this limit is 1. Absolute value of x times 1 is equal to absolute value of x. Are we good so far? Alright, so what is it that we were trying to do? We were trying to find the radius of convergence. What does ratio test do? Ratio test, does that help us figure out whether a series converges or not? What has ratio test got to do with this limit? Everything hinges on this limit, right? A series will converge. According to the ratio test, a series will converge whenever this limit is less than 1. So we can say, so the series converges whenever the limit, what's the limit? Oh, limit is absolute value of x. Absolute value of x is less than 1. You see how clever that is? Applying a ratio test, even though we have variables, works exactly like how it did for the constants. So absolute value of x. So the series converges whenever absolute value of x is less than 1. But we wanted to know what the radius of convergence is. Now here is where we need to look at what the definition of radius of convergence was. The definition said, if a power series converges whenever absolute value of x minus a is less than r, then we say r is the radius of convergence. A power series converges whenever absolute value of x minus a is less than r. We say that r is the radius of convergence. We have this power series in our example, and we have that this power series converges whenever absolute value of x is less than 1. Is this absolute value of x less than 1 looking like absolute value of x minus a less than r? Yeah, what is A? 0. What is R? 1. End of the story. So radius of convergence in this case is just 1 based on the definition of radius of convergence. Cool? All right. So what's the interval of convergence is the next question that we'll tackle. And that you got to pay a little attention. To find the interval of convergence, we have that the series converges whenever absolute value of x is less than 1. What does that mean? That means -1 is less than x less than 1. Right? So the interval of convergence is guaranteed to be -1 to 1. That interval, open interval -1 to 1 is guaranteed to be the interval of convergence. So the minimal interval of convergence, that's what I call it. Minimal interval of convergence is the open interval -1 to 1. But how come I'm not saying interval of convergence? What's up with this stupid minimal interval of convergence? Right? That is related to the ratio test. Okay, let's go back to the test that we applied. We applied the ratio test and we got the limit of absolute value of a sub n plus 1 over a sub n to be absolute value of x. What does ratio test say regarding convergence? When the limit is less than 1, converges. Greater than 1, diverges. Yeah, what does it say about when the limit is equal to 1? Do you remember? The test is inconclusive. So, ratio test cannot tell you what happens when the limit is equal to 1. That is the one that causes a little bit of an issue to claim that this is actually the interval of the entire interval of convergence. No, we do not know what happens when absolute value, when the limit is equal to 1. That is, when absolute value of x is equal to 1 or x is equal to -1 or +1. The end points. So the whole idea is, once you get the minimum interval of convergence based on that inequality for radius of convergence, absolute value of x is less than 1, you need to figure out what happens on the endpoints separately. You get it? So the next thing we'll do is, at each of these endpoints, we will look at what happens to the series. At endpoint x equals -1, we have, this is our original series. So we are saying, hey, plug x equals -1. Cool. When we do that, we have -1 to the n times -1 the quantity raised to n over cube root of n. What is -1 to the n times -1 to the n? Think about it. It's just equal to 1. -1 to the n times -1 to the n. Why is that? Is that equal to -1 to the 2n? A to the m times a to the n is a to the m plus n. So -1 to the n plus n, or -1 to the 2n. -1 when raised to 2n, which is an even number, will always be +1. Right? Or -1, the quantity square is 1, 1 raised to n is 1. Either way, so -1, so this just reduces to 1 over cube root of n. Now, it has become a problem from the previous sections. Determine the convergence of this. Look at how it is. Testing a series for convergence has become a small part of a big problem. Up until now, the whole thing was about testing for convergence. Now, the testing for convergence is just a small part. Welcome to upper classes. All right. What's the answer to this one? What test would you apply to figure out whether or not this series converges? I would say this diverges as a P series with P equals 1/3 less than 1. Right? Is this in the form of 1 over n to the P? Yeah, 1 over n to the 1/3. So P is 1/3, which is less than 1, so series diverges. Cool. Now let's look at endpoint x equals 1. So plug 1 for x. We have -1 to the n times 1 to the n. 1 to the n is just 1. So -1 to the n over cube root of n. That's what this becomes. The question is, does this series converge? What test do you apply? Clearly, this is an alternating series. Would you agree? So, apply alternating series test, which means b sub n is 1 over cube root of n. Limit of cube root of n is 0. So this guy converges. Okay. So what did we find? At the endpoint x equals -1, the series diverges. Whereas at endpoint x equals +1, the series converges. So the actual interval of convergence is, we will change the parenthesis where necessary. -1 diverged, so let's leave it as parenthesis. But at +1 converged, so let's change it to a square bracket. So interval of convergence I is -1 to 1. Left open, right closed. Cool? All right. Let's look at another one. Find RNI of n to the n, x to the n. Ooh. Radius of convergence and interval of convergence for this series. All right. Is this a power series? Yep, it is. C sub n is n to the n for all n in 1, 2, 3, 4, 5, 6, so on. And A is 0. Now, what test do we apply? I told you, ratio test is always a good idea. But for this one, we will apply root test. That makes life much easier. So apply root test, limit of nth root of absolute value of a sub n. So if we do, that simply reduces to nx. Nth root of n to the n, x to the n is just nx, absolute value of nx. And I can yank that absolute value of x outside, and we get limit of absolute value of n as n approaches infinity. Uh-oh. What is limit of absolute value of n as n approaches infinity? Infinity. And so absolute value of x times infinity. Oh, that's just infinity. Right? Okay, so what? Limit of nth root turned out to be infinity. Okay, what does root test say about what happens to the series convergence? Does the series converge or diverge? Clearly, even the root test says if the limit that you computed happens to be greater than 1, which infinity is certainly greater than 1, the series diverges. Okay, for what value of x? For all values of x. And let me not say all values. We need to be careful. What happens if x were to be 0? Well, I told you not too long ago. The series always converges for x equals a. A is 0. So the series certainly converges for x equal to 0 because every term would be 0 when x is equal to 0. So 0 plus 0 plus 0 plus 0 and so on is what you have. And of course, that sum converges to 0. So leave out that x equal to 0 part. And for any other value of x, this series diverges. So what is the radius of convergence? Can you think about it? What is the radius of convergence? 0. Right? from that center point, you cannot go anywhere to the left or to the right. I'm talking about that number line that I drew with A as center, which means A is 0 here, so 0 as center. Could you go anywhere to the left or to the right to see for what values of x does the series converges? You cannot. So radius is 0. Okay. The interesting question is, what is the interval of convergence? Did this series converge for any values of x at all? Yes, it did. It converged for x equal to 0. So what is the interval of convergence? Keep in mind one thing. An interval is nothing but a set. So when I ask you for an interval of convergence, you must give me a set. Okay. What set? A set of points for which this series converges. It doesn't converge for it doesn't converge for any value other than 0. Okay, so it does converge for x equal to 0, right? So your set contains 0. The interval of convergence is a set that contains the element 0 or the number 0. How do we write that? Right? And this is the way you write it. You enclose that in curly braces to indicate it's a single element in this set, and that element happens to be 0. A set like that is called a singleton. So we have a singleton for I with 0 as its element. Okay. Cool. I don't think this problem is in the book, so I just made it up. Okay, find Rni of x to the n over n factorial. Let's apply, oops. I should have changed the order. Recently added this. Oh man. Okay. So don't look at, come on. I'm sorry. Don't look at this series converges for all values of x and all that argument. Okay. Just focus on apply ratio test. Pretend as if you didn't see this. All right. Close your eyes. No, don't close your eyes. So limit of absolute value of a sub n plus 1 over a sub n. Right? That's what we do. That turns out to be x to the n times x. X to the n plus 1 is x to the n times x. N plus 1 factorial can be written as n plus 1 times n factorial times this thing. So x to the n's cancel. N factorials cancel. All we are left with is absolute value of x times limit of 1 over n plus 1. But 1 over n plus 1, as n goes to infinity, goes to 0. So we have absolute value of x times 0. That is 0. And it's clearly less than 1. So now, because this limit turned out to be less than 1, guess what? The series converges for all values of x. No matter what you plug in for x, this series is guaranteed to converge. Okay, that's the idea. So the radius of convergence is actually infinity, and the interval of convergence, remember, interval of convergence is an interval or a set. So that is just the real number set. You can also say open parenthesis negative infinity to infinity close parenthesis, right? So that you can say, or I equals R is perfectly fine. Cool. All right, let's look at another one. Ooh. All this time we had A to be 0. But here's a case where A is not 0. What is A? What do I mean by A? Sigma C sub n x minus A to the n. Right? Can you tell what A is? Yep, A is 1. And we'll apply ratio test. So limit of this thing, and I can ignore negative 1 to the n because we are taking absolute value, right? Okay, x minus 1 to the n plus 1 becomes x minus 1 to the n times x minus 1. And I'm replacing n with a n plus 1. So 2 times n plus 1 minus 1 becomes 2n plus 1. What? Yep. 2 times the quantity n plus 1 becomes 2n plus 2. We are subtracting a 1. 2n plus 2 minus 1 is 2n plus 1. That's why I have 2n plus 1 here. And for the 2 to the n plus 1, I wrote that as 2 to the n times 2. Cool. Dividing by a sub n, multiply by the reciprocal instead. That's what I did here. And as you can see, a whole bunch of things cancel. The 2 to the n's, 2 to the n's go away. X minus 1 to the n, x minus 1 to the n. And we would be left with an x minus 1 on the top and a 2n minus 1 over 2n plus 1. So we'll yank this absolute value of x minus 1. Ooh, by the way, there's a 2 also we can pull outside. It's a constant multiple. Pull that out, and so we are left with limit of 2n minus 1 over 2n plus 1. Right? What is this equal to? This limit of absolute value of 2n minus 1 over 2n plus 1? Well, ratio of leading coefficients. 2 over 2 is 1. So this just becomes absolute value of x minus 1 over 2. Isn't that nice? Cool. When does this series converge? Whenever this limit is less than 1. Right? What's the radius of convergence? So the series converges whenever absolute value of x is less than 1. What's the radius of convergence? Be careful. What exactly is, go back to the definition. If a series converges whenever, if a power series sigma c sub n x minus a to the n converges whenever absolute value of x minus a is less than r. So the first order of business is, can we write this in that form? Absolute value of x minus a being 1, is less than r. We have x minus 1 over 2 less than 1. Can we write this as absolute value of x minus 1 less than something? Yeah. If you multiply both sides by 2, does it change the inequality? If I have a less than b, can I multiply both sides by 2 and the inequality is preserved? The answer is yes. You can multiply by a positive quantity and the inequality does not change. So by doing that, we got absolute value of x minus 1 to be less than 2. Cool. Now, does that look like absolute value of x minus a is less than r? Yes, it does. So what is r? You guessed it, 2. R is 2. Cool. Now, finding the interval of convergence is a bit involved. So let's see. To find the interval of convergence, what did we have? We had that the series converges whenever absolute value of x minus 1 is less than 2, right? So what can we write this as? Negative 2 less than x minus 1 less than 2. Right? Going back to pre-calculus. If we have absolute value of x minus a is less than b, b happens to be a positive quantity, then we can say negative b less than x minus a less than a positive b. Now, if I add 1 to every term, then this becomes negative 1, this becomes x, and this becomes 3. So negative 1 less than x less than 3. Based on this, we can say that the minimum interval of convergence, minimal interval of convergence is negative 1 to 3. Cool. And what is left for us? The endpoints. The ratio test didn't tell us, was inconclusive what happens at the endpoints negative 1 and 3 of this interval, which is where this was equal to 2. Absolute value of x minus 1 was less than or rather equal to 2 in that case, right? So as before, we'll say, let's look at the endpoint x equals negative 1. Well, what happens? Excuse me. -1 to the n, the series became, really, even I lost track of why in the world it is. So let me go back. Okay, let's go back to this one. So let's plug x equals -1. What would this series become? -1 to the n, -1, -1. So that's -2. -1 minus 1 is -2. So this became -1 to the n times -2 the quantity to the n. Over all of this, the denominator is going to be the same. So that's what we were talking about here. Okay. Okay, -1 to the n. Okay, what is this in turn equal to? Well, if the exponents are the same, can I simply multiply the insides? And that is, make this equal to -1 times -2, the whole quantity raised to n? Let me repeat that. Because the exponents are the same, can I set this equal to, the top equal to, -1 times -2, the whole quantity raised to n? Yep, I can do that. So that makes the top equal to 2 to the n. So we have, I didn't need to do this. I could have argued the other way. Okay, so this became, and now this 2 to the n and 2 to the n, they cancel out, and -1 to the n times -1 to the n, like earlier I said, is equal to just 1 over 2n minus 1. So this is what the series reduces to. Now, a question for you. Does this series converge or diverge? By now, you should have become pretty good at this stuff, having solved those 140 problems. The answer is, yeah, we could actually compare this with sigma 1 over 2n. These terms are bigger than the terms of 1 over 2n. So 1 over 2n, sigma 1 over 2n diverges as a harmonic series, 1/2 times sigma 1 over n. So this series also diverges. Done. Now at the endpoint x equals 3, trust me, if you go back and plug x equals 3 into this, this becomes -1 to the n times 2 to the n over this thing. So 2 to the n's cancel, you get -1 to the n over 2n minus 1. Any ideas what test to apply? Yep, you guessed it, it's an alternating series, so we'll apply alternating series test, and it converges when we do that. Trust me on that one. So the interval of convergence is left -1 is divergent, so we'll keep that a parenthesis. The right 3 converges, so we'll change that to square bracket. Cool? That's the idea. Let's look at the next one. 2x minus 1 to the n. Is that a power series? Does that look like sigma c sub n x minus a, the quantity to the n? The quantity x minus a to the n? No, x was supposed to be, the coefficient of x was supposed to be 1. This stupid thing doesn't have the coefficient of x to be 1. So it's not a power series? Nope, it is a power series. Why? How? Okay, who's stopping us from factoring out a 2 out of this? Right? I could very well factor out a 2 and it would become 2 times x minus 1/2. Oh, 2 times x minus 1/2, the whole quantity raised to n, and the 2 times that, so that becomes 2 to the n times x minus 1/2 to the n. Yep, this is in fact a power series. Ooh, I should have been clever and asked you, what is a here? You know what I mean? a, x minus a to the n, c sub n, x minus a, the quantity to the n. Right? A, what is a here? Do not say 1. Because a, we have to have the form x minus a to the n. So if we factor out 2 out of this, we get x minus 1/2. So a is actually 1/2 in this case. Okay, cool. Again, let's apply ratio test, limit, and can I ask you to trust me on this one? And we end up with this. And limit of square root of n over square root of n plus 1 is just 1. So this reduces to absolute value of 2x minus 1 over 5. So, according to the ratio test, the series converges whenever this quantity, the limit that we got, is less than 1. Right? Okay. Can we figure out what the radius of convergence is? This is where you need to be a tad careful. Can we simply multiply both sides by 5 and say, yep, absolute value of 2x minus 1 is less than 5, so 5 is the radius of convergence? No, we cannot. What's the form for radius of convergence? A series must converge whenever absolute value of x minus a is less than r. We do not have the form, even if we multiply by 5 on both sides and get this, we do not have x minus absolute value of x minus a less than r. Because the 2, the coefficient of x must be 1. Here we have coefficient to be 2. So no big deal. Let's yank that out or divide both sides by 2. So that's how we get absolute value of x minus 1/2 is less than 5/2. Now does this look like absolute value of x minus a less than r? It does. So what is r? What is a, by the way? 1/2. And r is 5/2. Cool. This is a very interesting problem, and this is sort of my favorite problem. So typically I would give a question. I'll make up my own problem. Looking at this, what kind of a problem can I make up? Sigma 3x minus 2, the quantity raised to n, over 7 to the n times n square. Something like that I can easily make up, right? So I definitely want you to be able to see the nuances of a problem like this. How we don't just jump to the conclusion that the radius must be 5 or 1 or something like that and all that. So it's a very interesting problem. Cool. So we got the radius of convergence. Now let's go to interval of convergence. We have this, that the series converges whenever this, right? And that means negative 5/2 less than x minus 1/2 is less than 5/2. Add 1/2 to every term, and that reduces to negative 2 less than x less than 3. If you recall, as soon as we get that in that form, we can say the minimal interval of convergence is negative 2 to 3. And now we'll figure out at endpoints what happens at negative 2. Negative 2, we have the quantity 2x minus 1 raised to n. So for that x, I'm plugging in x equals negative 2. So 2 times negative 2 minus 1. So that becomes negative 5, the quantity raised to n. And negative 5, the quantity raised to n, can be written as negative 1, the quantity raised to n, times 5 to the n. 5 to the n, 5 to the n cancel, and it just reduces to this. Does the series converge? Apply alternating series test and this series converges. Okay. Next, at x equals 3, 2 times x, 2 times 3 minus 1 is 6 minus 1 is 5. 5 to the n over 5 to the n over 5 to the n, that just cancels, and we just left with 1 over square root of n. Does this converge? Nope. Why? P series with p equals 1/2 less than 1. End of the story. So the interval of convergence is -2 to 3. -2 is closed, 3 is open. Ladies and gentlemen, that's it.